Okay, this is the first part of our lecture on composites. So this lecture is lecture 1. It is Introduction to Composite Material. My name is Semayat Fanta, a PhD scholar from Indian Institute of Technology, Kanpur. And I placed my email address on this slide. Anyone can ask me any question based on this presentation using this email. So, objective of this presentation, at the end of this lecture, the learner will be able to identify the historical perspective of composite, what the composite material is, what is the essence of, or the essentiality of composite, brief definition of composite material, components of the composite material, role of composite material, and the components of the composite, type of composite material available, classification of composite, the common types of material for matrix and fiber, and finally the design requirement of composite. The first, starting from it's better to know the revolutionary of engineering materials. So engineering material constitute the foundation of technology, whether the technology pertains to structure, electronics, thermal, electromechanical, electrochemical, biomedical, or other applications. The history of human civilization evolved from the Stone Age to Bronze, the Iron Age, Steel Age, the Space Age, and currently Artificial Intelligence Age. Each age is marked by the advance of certain materials. The Iron Age brought tools and utensils. The Steel Age brought railway construction and industrial revolution. The Space Age brought some of the structural materials, like material for the aircraft, materials for the rockets, materials for different space vehicles. The Electron Age was brought about semiconductor materials. Materials like polymer composites, ceramic semiconductor materials, and other composites. Historical perspective of composite. So in 4000 BC, these fibrous composites were used in Egyptian in making laminates or writing material like paper. In 13,000, the reference to Book of Exodus. Starting from this time, the composite material goes to 19th century. That is, in 1990s, high temperature ceramic materials evolved and aggressively reached to the next generation aircraft engine and power plant turbines. Ancient Egyptian manufactured mud and straw to make adobe brick. That is the beginning of composite, man-made composite. Straw reinforced mud cited in Old Testament as organic fiber reinforcement. Glass fiber reinforced polymers in 1950s. Advanced composites like carbon-carbon composite, polymer matrix composite, metal-metal composites, carbon matrix composite started from 1960 to 1970s. And the advanced composites like carbon fiber reinforced polymers becomes dominant in 1970s. The carbon composites are applicable for thermal protection from 1970s. And the metal composites used especially in the application of automobile engine, electronics, thermal management. Composites are used as one of the 10 outstanding achievements of the era of 1964 to 1984. These composites, we can simply define it as a material system which consists of two or more materials combined to produce a material with improved mechanical properties over individual constituent materials. The two materials work together to give composite unique property. However, within the composite, we can easily tell the different material apart as they do not dissolve, react, or blend into each other. Some of the examples of composite: the flash in your leg reinforced with bone, concrete reinforced with steel, epoxy reinforced with graphite fiber are some examples of composite. Composites are multi-phase materials, obtained artificial combination of different materials so as to attain properties like individual components by themselves cannot attain. An example is a lightweight structure composite that is obtained by embedding continuous carbon fiber in one or more orientation in polymer matrix. Another example, concrete, which is a structural composite obtained by combining cement, sand, gravel, and admixtures, the aggregate components or the aggregate combination of these two. The main causes of composites are polymer matrix composite, cement matrix, metal matrix, carbon matrix, and ceramic matrix are the main class of composites. The essentiality of composite. The essence of composite concept of composite is the load applied over large surface area of matrix, and matrix is then transferred the load to reinforcement, which being stiffer, increasing strength of the composite. It is important to notice that there are many matrix materials and even more fiber types, which can be combined in countless ways to produce just a desired property. In the United States, composite manufacturing companies produce about $2.5 billion per year. There are about 6,000 composite-related manufacturing plants and material distributors across US. The industry employs more than 235,000 workers, and additional 250,000 people are employed in business that support the composite industry, including material suppliers, equipment vendors, and support personnel. Already, as I tried to define composite, they are a combination of two or more materials in which one of the material is called reinforcing phase and is embedded in another material called matrix phase. Typically, the reinforcement materials are strong with low density, while the matrix is usually ductile or tough material. If the composite is designed and fabricated correctly, it combines the strength of reinforcement with toughness of the matrix to achieve a combination of desired properties not available in any single legacy material, such as aluminum, steel, or titanium also. About 90% of composite produced are comprised of glass and carbon fiber and either polymer or vinyl ester resin. Composites made from this type of material known as reinforced plastics. The composites are materials, still the third definition for the composites are materials of two or more physically distinct phases, whose combination produce aggregate property that are different from those of its parental materials, or they are composed of two or more chemically distinct materials. This means they are not chemically react when combined to have improved property of they merge completely into each other. So we have fiber and matrix, the two phases of materials or two distinct phases, which when they are combined properly, it produces a composite with new material with synergistic effect. Nearly all composite materials consists of two phases of material. That is primary phase, which is form the matrix within the secondary phase is embedded on it. Example of matrix material are polymers, metals, and ceramics are example of matrix. Secondary phase, or this is called reinforcement phase, which embedded phase sometimes referred to as reinforcement agent, because it usually serves to strengthen the composite. The reinforcing phase may be in the form of fibers, in the form of particles, in the form of flake, sheet, or other various geometries. Example of reinforcing phases are carbon fiber, glass fiber, Kevlar fiber, boron fiber, metal fiber, ceramic, and organic fibers. Here, what we are calling carbon and glass, that is, they are both of the carbon materials. Carbon having about 93 to 95% of carbon in the content, and glass is actually not glass, but that glass is of more than 99%. So this is one type of carbon reinforced polymer matrix laminate. It contains reinforcement material, it contains fiber, and also nano composite matrix in it. Function of constituent material in composite. Matrix has its own function, that it binds and protects fiber from environment, distributes the load evenly between fibers so that all the fibers are subject to equal strain, enhances transverse property of the laminate, because in the transverse direction, the reinforced materials getting weak property, so that will be enhanced using this thing. Improve impact and fracture resistance of component, and carry interlaminar shear stress. Fiber material, it is the secondary phase of the composite, which embed into the matrix and reinforce it, exhibit high tensile strength and high modules, but are susceptible to damage, particularly impact damage. Embedded phase in the form of fibers, particles, and flakes. The property of composites are derived primarily from the fiber reinforcement. General classification of composite. We have two classifications. Yes. Hello? So, two classifications, that is natural composites and synthetic composites. The most common natural composites are wood, concrete, and asphalt are the natural composite, and the synthetic are modern material system normally associated with the manufacturing industry, in which the components are first produced separately and then combined in controlled way to achieve a desired structure, properties, and part geometry. Natural composites. Natural composites are composites those exist in both animal and plants. For example, bamboo is a very lightweight yet stiff structure. The composite fishing poles and golf clave shafts are the parts which we get from bamboo. Natural fibers, any hair-like raw material directly obtained from the animal, vegetable, and mineral sources, and convertible into non-woven fabrics such as felt or paper, or after spinning into yarn into woven clothes. Natural fiber components may be wood, sisal, hemp, coconut, cotton, canaf, flax, jute, abac, banana leaf, and bamboo and white straws are others. Animal fiber may be further defined as agglomeration of cells in which the diameter is negligible in comparison with the length. Also, natural abundant in fibrous materials, especially cellulose types such as cotton, wood, grains, and straw. Only a small number can be used for textile products or other industry purpose. Apart from economic consideration, the usefulness of fiber for commercial purposes abrasion resistance, absorbency, and various surface properties. Most textile fibers are slender, flexible, and relatively strong. They are elastic in that they stretch when put under tension and then partially or completely return to their original length when a tension is removed. The fibers are classified into three parts. The plant or cellulose base, which are fibers include cotton, flax, and jute. The animal or protein base, fibers include wood, which consists of cellulose fiber and held together by a substance called lignin. Cellulose fiber provides strength, and the lignin is the glue that bonds and stabilizes the fiber. It is a living structure combining strength and flexibility. Excellent insulator when compared to metal, plastic, and concrete. So we have wood, and wood have a lot of different structure that has its own function. These are some of the plant or cellulose-based natural products like jute, coir, bamboo, hemp, sisal, and others. This is an animal-based natural. For example, bone is one of the natural composite which contains collagen fibers with mineral matrix. And human is also one of the part which is considered as composite because of the components that the outermost enamel strong part, the middle dentine, and the inner soft pulp parts are there on it. The wool products, other natural available composites like cotton from plant, silk from the silkworm, hair from the rabbits and goats, wool from the sheep, and others. The typical mechanical property of natural fibers and natural composites. I placed two things here. The first part is the natural fibers like flax, jute, coir, banana, sisal, pineapple leaf, and asbestos. So the density of each of them given here, the tensile modulus in gigapascal given here, the tensile strengths in megapascal are given for each of. And the combination of the composites which obtain from that, for example, bone consists density of 1,870 kilogram per meter cube. The tensile modulus 28 gigapascal, tensile strength 140 gigapascal. Like that for all of this bone, ivory, balsa. This balsa is very light metal, which is most of the time model aircrafts are made from using balsa wood. So that is very important in aerospace industry. Spruce, bridge, oka, bamboo, these are the natural existing composites. Drawback of natural composites. Unlike most synthetic fibers, all natural fibers are non-thermoplastic. That means they do not soften when heat is applied. Natural fibers tend to yellow upon exposure to sunlight and moisture, and extended exposure results in loss of strength. All natural fibers are susceptible to microbial decomposition, including mildew and rot. Cellulose fibers are decomposed by aerobic bacteria and fungi. Cellulose mildews and decompose rapidly at high humidity and high temperature, especially in the absence of light. Wool and silk are also subject to microbial decomposition by bacteria and molds. Animal fibers are also subject to damage by mouse and carpet beetles. So the next part is the synthetic composites. That synthetic composites are made from two or more which are combined together in a physically distinct phase or chemically distinct material to produce some desirable properties. So among them, the metal composites, the ceramic composites, the natural composite, the polymer composites, forms, and the composite of fiber like carbon fiber reinforced polymer, graphite fiber reinforced polymer, Kevlar fiber reinforced polymer, glass laminate reinforced are some of the synthetic composites. So we can classify synthetic composites based on the fiber material as well as based on matrix material. So the first classification is based on the reinforcement fiber. Composites are three classes: particle reinforced, fiber reinforced, and structural. The particle reinforced also large particle, Persian strengthening particle, fiber reinforced, continuous fiber reinforced, discontinuous or short fiber reinforced. Structural composites are like laminates, which made from a number of plies stuck together to form a single laminate. So laminas are stuck together to form laminate. And sandwich panels are also another, which are made from honeycomb structure with a faceplate of metallic material. They combine or stuck together to form a lightweight structure. So the fiber types which we are commonly using in composite are glass fiber, boron fiber, carbon fiber, silica fiber, and silicon carbide are the fiber types. The second classification is classification based on matrix material. So composite based on matrix materials, there are three classifications: ceramic matrix composite, polymer matrix composite, metal matrix composite. Ceramic matrix consists of a matrix of carbon, matrix of silicon carbide, calcium aluminum silicate, lithium aluminum silicate, and the metal matrix composite consists of aluminum, titanium, copper, magnesium, and other metallic materials. Polymer matrix composite consists of two big classes of materials in the polymer: that thermoplastic matrix composite and thermosets. The thermoplastics consists of polypropylene, polyvinyl chloride, nylon, and others. Thermosets are polyester, epoxy, and polyamides. So these are already what I have the three class of matrix-based composites, and this is the general classification containing matrix-based and fiber reinforcement-based. So advantage of composite materials, that when we are saying advantage of composite material, we are comparing the composites with the legacy materials. When I say legacy, the materials that conventionally what we are using for the aircraft or for the structural purpose or for different purpose. So based on that, composites are very strong, stiff yet very light in weight. So the ratio of strength to weight, this is what we call specific property, and stiffness to weight are several times greater than steel or aluminum. Fatigue properties are generally better than common engineering materials. Composites do not corrode like steel. Toughness is often greater. Possible to achieve combination of properties not attainable with metal, ceramic, or polymer. Fuselage and wings of an aircraft must be lightweight. This is the design requirement of the aircraft structure. And be strong, stiff, and tough. Several fiber reinforced polymers possess this combination of property. For example, natural rubber alone is relatively weak, but after adding significant amount of carbon black, increase its strength dramatically. Advantage of composite. Higher is this actually almost what I have stated, but some ideas like excellent grip and fatigue life strength, control electrical conductivity, tailored design. That means we can design any shape which cannot easily made from other material, and dimensional stability is also another important advantage that we can gain from composite material. The limitation of our, we can call it as some disadvantage on it, that composites are highly heterogeneous and highly anisotropic, that the directional property change. Difficulty to inspect using ultrasonic, that conventional inspection method like ultrasonic, eddy current method, or non-destructive indentation or non-destructive testing methods. High cost of raw materials and the fabrication, because the price of fiber, especially if we take carbon fiber, the price is very high. Slow and costly manufacturing methods, susceptibility to damage, particularly impact damage. They are very weak in impact, these composites. Weak matrix dominated transverse properties, that the transverse direction is, there is no reinforcement fiber in the transverse direction, because reinforcement is placed in the longitudinal direction. So the transverse is only matrix dominated, so that it is weak in the transverse. Difficult to attain with fasteners. That the use of fasteners also, that drilling of holes on the structure can cause another accident, so that it is difficult. Complex mechanical characterization and difficulty of analysis. That material homogenization or characterization is very difficult when compared with other materials. Complicated repair, reuse, and disposal of composite structure. And high combination of all required properties might not be achieved. Hybrid composites. These are another class of composites which are consisting of two constituents at nanometer or molecular level, that very small 10 to the power of -9 level. The compounds are inorganic and the other one is organic in nature. They differ from traditional composites where the constituents are at the microscopic, that is micrometer, means 10 to the power of -6, or millimeter 10 to the power of -3 meter level. Mixing at microscopic scale leads to more homogeneous material that either show characteristics in between two original phases or even new properties. Hybrid materials can be classified based on interaction connecting the inorganic and organic species. So there are two cases. The first case is those that show weak interaction between the two phases, such as van der Waals, hydrogen bonding, or weak electrostatic interactions. The second one, or the second phase, is those that show strong chemical interaction between the components, such as covalent bonds. Advantage of the use of hybrid material over traditional composite. Inorganic cluster or nanoparticles with specific optical, electronic, or magnetic properties can incorporate in organic polymer matrix. Contrary to pure solid state inorganic materials that often require a high temperature treatment for their processing, hybrid materials show a more polymer-like handling, either because of their large organic content or because of formation of cross-link inorganic network from small molecular precursors, just like polymerization reaction. Application of composite material. So composites are applicable in many fields of mechanical engineering, like automobile industries. Previously, we are using steel and aluminum for most bodies of cars, but that is directly substituted with composites in modern cars. In submarine applications like shafts, hulls, spars, in aerospace application like parts of or components of rockets, missiles, aircrafts, and communication antennas, electronic circuit boards, safety equipment like ballistic protection and airbags of the car, wind power and turbine blades manufacturing. For this, currently we are using composites, or throughout the world people use composites. These composites are also used in recreational centers for the different material manufacturing, sport goods. The mechanical properties of man-made structural, just as a sample for unidirectional composites like graphite fiber reinforced, carbon fiber reinforced, Kevlar fiber reinforced. I specify some important properties like specific gravity, tensile modulus, tensile strengths, compressive strengths, specific tensile module, because specific properties are very important. Specific tensile strengths, specific compressive strengths, and these values are already placed in the table. The shipment of composite. For transportation purpose, 31% of composites are used. Construction industry use 20%. Marine industry 12%. Corrosion resistant equipment application 12%. Electrical and electronics 10%. Customer products 6%. Appliance and business equipments 5%, and the others are 4%. This is actually the data shows of 1995, but currently even the application is very high. World market of composites. So for aircraft purpose, for missile and space purpose, for recreational purpose, for armor or military purpose, automotive purpose, industrials or other applications. So the here it shows the volume of composite used for aircraft 7.3, the volume of for missile and the spacecraft 5.1, for recreation 5%, for armors 4.3, and so on. Factors to be considered during material selection. In selecting, this is actually design part. When we are designing any component, we must consider different factors that affect for the use of the material. And selecting composite material, an optimum combination of properties is usually sought rather than one particular property. Weight consideration is one of the design idea. Strength consideration. When we come to weight, water is, as we know, that is the standard, or that we start to consider other masses based on water. So armide fiber, or in general name called Kevlar fiber, 1.3 to 1.4 gram per cc. Carbon fiber, 1.79 gram per cc. And fiberglass, 2.4. So for lightweight construction, armide fiber or carbon fiber are obviously useful. Strength consideration. Carbon fiber having 5,650 meg 57 is still 570 megapascal. So in the case of strength consideration, obviously we have to use the carbon fiber rather than steel, because steel is very small when compared with even more than 10 times less than carbon fiber. Stiffness consideration. So carbon is given 30 to 40, armide fiber 14, and fiberglass 10 to 13. So obviously armide fiber have good stiffness. Again, impact resistance condition. So armide fiber is highly impact resistance than fiberglass, and fiberglass is better than carbon fiber. Cost consideration. Actually, this is not exact value, but based on some statistics, fiberglass, the cost of fiberglass per kg, or no, per LB, it is 5 to 8 ton. Armide fiber, 20 ton. And carbon fiber is 30 to 50 per ton. So that based on cost, glass fiber is in better range of cost than carbon. So we have to combine these things while we are designing any material. So this is what I have today. Thank you very much.